acyl bromide. So all these functional groups which can undergo the hydrolysis are esters, amide and substituted amide, acyl chlorides, acyl bromides, haloalkanes, and chlorobenzene. Chlorobenzene. Now, let's see how they undergo the hydrolysis. Starting with ester. Ester is this functional group, general. Amide is this. And substituted amide is RCONH, and then there is another R. So please look at this. RCONH2 amide hota hai, and then when one of the hydrogen on the benzene is replaced with alkyl, so it is an substituted amide. Okay. Similarly, RCOCl is acyl chloride. R is alkyl. Okay. COBr is acyl bromide. R CH2. I can write RCl, but I just on purpose I'm writing it RCH2Cl is a haloalkane, and you know the chlorobenzene or aryl chloride. You also call it aryl chloride. Okay, this is C6H5 when chlorine is attached with aromatic ring or benzene ring. When Cl attached with benzene ring. Okay. Now coming back to this, how all these compounds, so we're going to put all the hydrolysis together on this day. For example, look, when the ester undergo hydrolysis, you need to understand that this is the bond between CO and O. So it is usually the bond between C double bond O and any other foreign elements. I mean, oxygen, nitrogen, or something like that. That always breaks. And this part gets OH, and this part gets OH, because hydrolysis is actually the reaction with water. Similarly, in amides, which bond is going to break if you follow the pattern? C double bond O ka, the bond which is NH2. So this part is gonna get H and this OH. Similarly, now you know the pattern. C double bond. Every time C double bond O ka jo bond hota hai with other than carbon jo element hota hai, nitrogen, oxygen, chlorine, jo nitrogen, oxygen या chlorine से होगा, right? That breaks. और C double bond O को हमेशा water का क्या मिलता है? और the other part, whatever the left is H. Similarly, यहाँ भी यही होगा. C double bond O का वो bond जो Cl से है, वो break होगा. This part gets H, this part gets OH. Similarly, when this bond breaks, इसको H और इसको क्या मिलेगा? OH. Similarly, in this case, as there is no CO, so obviously this bond breaks, right? And this part is going to get OH and this H. Or if you... No, the water is OH, right? And the last part here, if it breaks, Same goes with this. Okay. Now, one thing which you need to understand, which bond breaks during the hydrolysis. So 90% organic reactions are based on hydrolysis. So you can expect in your exams, the organic chemistry which they give you, one of the reaction will be based on hydrolysis out of all these. Now, if you look at the reagent and conditions for all these, up to this point, these three, the ester, amide, and N-substituted amide, they can't react directly with water. So what you have to use either acidic hydrolysis or alkaline hydrolysis. For all these. Right? For example, acidic and alkaline. Okay? So acidic hydrolysis and alkaline hydrolysis. Okay? For acidic hydrolysis, look at this. You are using either dilute HCl aqueous, right? Or dilute NaOH aqueous. Okay? So when you use the acidic hydrolysis, look at this. The ester reaction to water ke saath hi hai na? Dilute acid and dilute alkali. So the products for this, for example, is going to be RCO. I'm just writing the product for the ester only, this one. So one product will be what? RCOOH, carboxylic acid. And the other product will be what? ROH, yani alcohol. On the other hand, when you do dilute NaOH aqueous, the one product is, please pay attention. Now the products are the same, the carboxylic acid and alcohol. But in one product, RCOONA, the salt of carboxylic acid, because product to wahi hai carboxylic acid, but carboxylic acid is formed in a mixture that is already containing an alkali in the same beaker. So as soon as that carboxylic acid is formed here, yes, it reacts with NaOH to form what? Salt. Right? So RCOONA is formed plus the ROH, I mean the alcohol, right? So the other product is alcohol. Okay, so all right, so similarly, now can you tell me, anyone, this was with the ester, okay? What about the amides? Yeah, one of them is again the carboxylic acid. Look, COOH. But the other product, NH3. But NH3, when you have an acidic hydrolysis, we understand NH3 is the base. So as soon as it is formed in an acidic solution, it turns into what? NH4 positive. So the other is ammonium ion. And it depends which acid you are using. If it's a ammonium if it's a dilute HCl, so ammonium chloride will be formed. If it is a sulfuric acid, so ammonium sulfate will be formed. Okay? Hmm. Yeah. The other side is what? And if you take the alkaline hydrolysis, so this is results of the acidic hydrolysis. What about the alkaline hydrolysis? One will be salt of carboxylic acid and the other one is now purely ammonia because ammonia formed is NH3 aqueous. Okay? When this undergoes hydrolysis, एक तरफ को H, एक तरफ को OH मिलेगा. What is the product? Carboxylic acid and then NH3. Because that NH2 ना वहां से ब्रेक हुआ मॉलिक्यूल तो NH2 को एक H मिला ना वाटर का तो फिर ये इधर वो NH3 बन गया. But if you are doing it with this acidic hydrolysis, this one, if you are using acidic hydrolysis, then your products will be RCO and H plus, ये amide के लिए बता रहा हूँ, plus NH4 positive. And for alkaline, your products will be RCOONA plus NH3. Okay? Next. Next. No, unsubstituted amide. What about this? When they undergo hydrolysis, what is formed? RCOH, carboxylic acid, plus RNH2, which is an amine. But amine again is a base. So as soon as it is formed, acid is already there. So it's going to accept the proton from that and going to turn into RNH3 positive. Okay. So the product for this are what? RCOOH plus RCNH3 positive. I mean RNH3 positive. It was amine, but amine formed in an acidic solution accepts the proton, so RNH2 turns into what? RNH3 positive. And what about this? Plus RNH2 amine. Okay? So these are the hydrolysis of ester, amide, and substituted amide, which need either acid or alkali to be to undergo the hydrolysis, and these are the products which are formed. The examples we have already done in our previous lesson, so examples you can follow from there. Here we are just giving an overview. Look at this. Now come to this acyl chloride. The acyl chlorides do not need acid or alkali to undergo the hydrolysis. They purely react with cold water. And very vigorous, very fast reaction takes place, right? Now, the bond breaks from the same place. So what is formed? RCOH, I mean carboxylic acid, plus HCl. So as there is no alkaline hydrolysis, so there is no acidic hydrolysis. So the products are this. Similarly, RCOBr, acyl bromides will give what? RCOOH. No, what I said just. They don't need any acid or alkali. They react with the cold water, the direct cold water. Okay? So they don't need anything, acid or alkali, to undergo the hydrolysis. They react with the cold water. Similarly, they react with cold water. तो क्या बनेगा? RCOOH plus HBr. Now come to haloalkane. Haloalkanes are different. they don't react with water or acidic. They undergo hydrolysis when they react with sodium hydroxide. So they directly undergo alkaline hydrolysis. So इनकी सिर्फ alkaline hydrolysis होती है. So instead of reacting with water, they react with sodium hydroxide aqueous. Rule is the same. The OH is come and it's going to be RCH2OH and alcohol plus NaCl. A salt is formed. Right? This is called, if you remember, nucleophilic substitution reaction or alkaline hydrolysis of haloalkane. This is the reaction actually we did in AS syllabus. Okay? And now the last but not the least, benzene ke saath when chlorine is attached. This one. And as we said before, the one benzene ke saath attach hota hai, the Cl, so aryl chloride, the bond is so strong now that even with cold water, with acid, with alkali, they do not undergo hydrolysis, right? So it's kind of no hydrolysis or lack of hydrolysis, right? Now the point is, if we have to explain this and then we have to compare these three acyl chlorides, acyl bromides, haloalkanes, and aryl chlorides, and we have to compare their relative rate of hydrolysis, right? Not with esters and imides, because you understand कि उनका एक different procedure है. They undergo hydrolysis with sodium hydroxide and HCl, acidic or alkaline. इनका procedure different है. So we are going to explain this procedure now. Okay, how acyl chloride, acyl bromide, and haloalkanes and chlorobenzene, the aryl chlorides, how they relatively undergo relatively rate, right? So now let's compare the relative rate of hydrolysis. Relative rate means relative speed of hydrolysis. किस की? RCOBr, RCOCl, RCH2Cl, and C6H5Cl. Okay? Now, the rate of hydrolysis in all these cases, you see which bond breaks. When the hydrolysis takes place, कौन सा bond break होता है? CL वाला bond ये हमेशा break होता है. So that's why the rate of hydrolysis always depends on this bond, the strength of CX bond. Right? क्योंकि यही bond टूटना है और जितना stronger bond होगा उतनी rate या speed of hydrolysis would be less or would be harder to hydrolyze, right? The strong CX bond mean hardest to hydrolyze, hence lowest speed of hydrolysis. Okay? So सबसे कम speed of hydrolysis होगी अगर ये bond सबसे ज़्यादा strong होगा. Now we have to focus. Whenever they ask you the rate of hydrolysis, you have to focus the bond between C and X. Okay? Carbon and halogen here. Okay? Now look at this, for example. What about this? If I compare the haloalkane with acyl chloride, I'm starting with this. So we say that this C double bond O, as we know that oxygen ki electronegativity is very high. So this C double bond O acts kind of EWG. EWG means electron withdrawing group. So it pulls the electrons towards itself. Yes, making this CCl bond very weak. So that's why this is easier to break. On the other hand, please look at this. Exactly the opposite way this works. Okay, the alkyl group attached in haloalkane is EDG, electron donating group, having a positive inductive effect. जब positive inductive effect होगा, electron donating group है, तो क्या होगा? The CCl bond would be stronger, harder to hydrolyze. So that's why the acyl chlorides are easier to hydrolyze, or their rate of hydrolysis is more. Because what you have to say, in acyl chloride, C double bond O acts as electron withdrawing group, right? For negative inductive effect. Yes. It's a negative inductive effect we कहते हैं. Negative inductive effect. Okay. Making CCl bond weaker. Yes. Easier to hydrolyze. Okay. On the other, no, that's beyond that point. Na? So with very next to that, वो उस R group की भी electron density अपनी तरफ खींच लेता है, इधर वाले की भी. So doesn't let it go towards that side. Okay, so it's a kind of electron withdrawing. So easier to hydrolyze. Okay, or more rate of hydrolysis as compared to haloalkane or alkyl chloride. Haloalkane or alkyl chloride. Yeah. Where alkyl group. Now I'm giving extra explanation. You can give only one of them. Either you can say C double bond O is the electron withdrawing group, or you can say alkyl group is electron donating. So I'm giving extra information, but whatever you want, you can write it. Where alkyl group is EDG, electron donating group, positive inductive effect. Making CCl bond stronger. And harder to hydrolyze. अब इसलिए इनको हमने इस तरह ऑर्गेनाइज कर दिया. What about C6H5Cl? And it is the hardest to hydrolyze. Why it is the hardest to hydrolyze? I just told you. I think we learned it previously. कि जो Cl है इसमें एक lone pair of electron होता है, which is localized over the benzene ring, known as mesomeric effect. Because of this mesomeric effect, this CCl bond, so hence it is the hardest to hydrolyze, even stronger than haloalkane. Okay, so haloalkane में जो CCl bond होता है वो उससे भी ज्यादा stronger हो जाता है, right? तो in aryl chloride, the CCl bond is strongest because of mesomeric effect or because of lone pair of electrons lone pair electron of chlorine delocalized over the benzene ring making CCl bond very strong and hardest to hydrolyze, almost not possible to hydrolyze. Now, what about acyl bromide? Yes. Now we see in dono mein to they have the same thing, C double bond O. But now the difference comes here, the bond length. CCl bond and then CBr bond. CBr bond length is more because of more atomic radius. So yahan you are not supposed to compare the CO ka bond because wo to dono mein hai. What we have to see that CBr bond जो है वो bond length ज़्यादा होने से उसकी bond strength क्या हो गई है कम हो गई, right? So in the last that CBr bond length increases as compared to CCl bond and so as bond strength decreases, making it easiest to hydrolyze. Okay, so सबसे आसान, this is the order of hydrolysis for these compounds. This is easiest and this is the hardest. And as I said before, I'm telling you again, you have to compare whenever they ask you. First, you put them in, and as far as the examination is concerned, first you put them in order like this, which one is the easy and which one is the hardest, and then you explain them in pairs. You can't compare all of them. So as we did, we compared this Cl and Br, then we compared haloalkane with acyl chloride, and then we compared the haloalkane with the last aryl chloride, right? So you have to compare two, because you can't compare all of them together. So this is how the hydrolysis, the rate of hydrolysis of these compounds, और उसके साथ मैंने आपको acidic or alkaline hydrolysis of, this is the all hydrolysis with one more example. Sorry, I forgot. That is nitriles ki hydrolysis. So there is one more organic compound that can also undergo hydrolysis with this, is nitriles. They can also undergo hydrolysis, but they are the ones which we did in AS. If you remember, if this is RCN, they also undergo acidic and alkaline hydrolysis. And if you have acidic and they have alkaline hydrolysis, like dilute acid or dilute alkali, so it turns into CN, turns into what? COOH. So one of the product is again carboxylic acid, plus in this case, you remember NH4 positive ban jayega. And if it is done with the alkaline hydrolysis, it becomes NH3 aqueous. So this is all about the hydrolysis. Jitne bhi hydrolysis ke reactions they we have just clubbed them together in this. So, or most of them or all of them, they produce carboxylic acid as one of the product. सिर्फ haloalkane के अलावा, right? Because they undergo the alkaline hydrolysis, right? That's all about the hydrolysis and the relative rate of hydrolysis.